Welcome back to video number 3 of our Intro to Limits and Asymptotes series. Here's the final problem. CV is organizing an event for alumni. The planning committee decides to rent a large space and get dinner catered. The space costs $600 for the evening, and each dinner is an additional $20. To honor the 5 oldest alumni, the committee will not charge them for dinner. Instead, their dinners will be included in the total cost to the committee. The committee simply wants to break even, not turn a profit. So, let's fill in this table to get an understanding of the cost structure. Suppose that 30 people attended. How many would be paying? That would be 25, because remember, the 5 oldest don't have to pay. If 100 people attended, then 95 people would be paying. If 200 people attended, then 195 people would be paying. And if X people attended, how many people would be paying? Well, notice the relationship between the first row and the second row. We always have to subtract 5 from the top row to get the second row, so it would be X minus 5. Next, we're going to calculate the total cost to the committee. So they have to buy dinner for everyone, whether or not that person is paying. And dinner costs $20 per person. So for the first one, it's $20 per person times 30 people plus $600 to rent the venue, and that total is $1,200. For the second one, it's $20 per person times 100 people having dinner plus $600 for the venue, and that is $2,600. For the third one, it's $20 per dinner times 200 dinners plus $600 for the venue, and that is $4,600. And now we're going to generalize. So we have $20 per dinner times X dinners plus $600 for the venue. Next, we're going to find the cost per paying attendee. So they bought 30 dinners, but only 25 people are paying. So we have the total amount of money, $1,200 divided by 30. Divided by, not 30, because only 25 people are paying. Sorry about that. So that should be $48. However, knowing where this is going and knowing that we want to create a formula, would it be better for me to leave it like this? I think it's okay if we go ahead and put $48. That should be fine. Okay, so the next one is $2,600 divided by the number of people paying, 95 people paying. And that works out to be $27.37 per person. So that is per paying attendee. The first one was $48 per paying attendee, and the second one is $27 per paying attendee because they're spreading out those costs over more people. The third one would be $4,600 divided by 195 paying attendees, so spreading the costs out more. So the extra costs that they're spreading out are the cost of renting the place for $600 and the cost of paying for the 5 free dinners, right? Or the dinners that cost $20 each, but those 5 people aren't paying. So basically there's $700 extra that is being spread out over more and more and more people, which is why the cost is going down as you increase the number of people. Now let's generalize. So we had the total cost, 20x plus 600, and we're dividing it by the number of people who are paying, which is x minus 5. So under that, we're asked to write a function. So we need a name like f of x or something, although because it's cost, maybe we'll call it c of x, c for cost. The cost per paying attendee, that's what we actually just figured out. Now we're just being asked to write it as a function. So c of x equals 20x plus 600 divided by x minus 5. And hopefully you realize, based on all the work we did earlier in the lesson, that this is a rational function, and so it will probably have a horizontal asymptote, a vertical asymptote. We could find limits and all that kind of thing. What is the domain in the context of the problem? So if all you do is look at this mathematically and you say, what values can x take on? And you notice that you can't have x equals 5 because that would make the denominator 0. You might say the domain is just all real numbers except 5. But it says in the context of the problem, meaning could you have negative numbers of people attending? Could you have one person attending? I mean, what makes sense? So if there are going to be 5 free dinners, you're going to have at least 6 people. So I would say that x has to be greater than or equal to 6, but also you can only have a whole number of people. You can't have 6.2 people or 6.8 people. So x is a whole number. Okay, the graph has a horizontal asymptote. What does it mean in terms of this problem? So I'm going to go ahead and pull up my graphing calculator. And here's the function already typed into the calculator. And then thinking about what would make sense for a window, since x is the number of attendees, I let x go from -2 to 500. Now, we know it's not going to be a negative number of people, but I'd just like to put a negative number in my calculator so that I can see the y-axis when I graph. And then for the y values, that would be the cost per person. I let it be -10, not because there's ever a negative cost, but because I want to see the x axis when I graph. And then I made the maximum y value 60, although I'm not sure if that's high enough, but remember we got a $48 cost per person when we had 30 people attending, so I figured 60 was probably a fairly good number to plug in there. And now let's look at the graph. So this looks like 1/2 of a rational function graph. If we looked at a different window, we would probably see the other curve on the other side of the axes, but this is the part we want for the domain for this problem. So notice that it's flattening out. What level is it flattening out to? So as the number of people goes up and up and up, if I press trace and I move along the graph, what is the y value getting closer to? So those people are sharing that extra $700. More and more and more people are sharing that extra $700. So really, because it's being spread out among so many people, the cost is getting closer and closer to just the cost of the dinner. Now what if I let x be even bigger? What if my x max was 1,000 people? You can see it's just getting flatter and flatter and flatter. And we look at what's happening to the cost per person. It's getting closer and closer to what? Just the cost of the dinner, $20. So if we go back, the graph has a horizontal asymptote. That horizontal asymptote is y equals 20. What does that mean in terms of this problem? The more people attend, the closer their cost gets to $20. Their individual cost. And that does say closer, it doesn't say doser, but I'll just go ahead and rewrite it just for fun. The more people attend, the closer their cost per person gets to $20. Okay, there we go. There is an application of a rational function. Thank you for watching and listening. Have a great day.